My name is Jinfeng. I'm a researcher at Nokia Bell Labs in New Jersey, USA. My research primarily focuses on the fundamental limits of wireless communication systems. We are looking at what's the limit a system could achieve in theory and use these findings to advise over, say, the design of the system design to find a better performance-cost trade-off. And lately, our focus is on millimeter wave communications, and we collaborate with many universities like Columbia and USM here, PCV, and to doing millimeter wave measurement. For example, here this sounder is 28 gigahertz, and you have another sounder 60 gigahertz. And yeah, so that's we will derive from those measurements some better understanding about the channel, how the wave propagate. So we have better idea how to design a communication system for that purpose. Oh, well, for example, this visit right now is I come to discuss the research directions, the new research directions for millimeter wave measurement. Now we have both capability to measure the channel at 28 and 60 gigahertz. And there's kind of two types of questions we want to figure out. First is what kind of new measurement design we could come up with so that we can test some hypotheses regarding their frequency dependency, right? The other is, so basically the frequency dependence means if some key channel characteristics will change when you move from 28 to 60 or higher frequency, right? The other thing is one big benefit of moving to millimeter wave is you have much wider bandwidth. But the downside is the communication range is reduced. So for that kind of system capability, what the kind of relevant applications the use of this communication system would be in the next 5, 10, 20 years. And if we could figure out what's the most relevant applications, and those applications would need some system requirement, need to us to understand the channel in that specific settings. For example, is the communication to cell phones, to moving cars, or just to your VR, AR goggles, right? So what's the main application scenarios for those communications? And correspondingly, we should design the measurement campaign to aiming those deployment scenarios to better understand the channel. Yeah. I think right now, especially in the US, the channel measurements and channel modeling, and of course system design applications in the millimeter range is very hot. And the largest operator in US, Verizon, is basically focusing on 5G, the 5th generation wireless communication on millimeter range. So they have a huge interest to understand what's their limit of providing high-speed coverage, both to residential and commercial business customers. And and also the industry itself, like Nokia as a business vendor, we are eager to learn the capability or the limitations of millimeter wave, using millimeter wave to provide, say, coverage, communications for industrial settings, for private enterprise, for like indoor office and, say, some other public domains, large area coverage. So we really need to understand the channels for those specific but representative environment. So that's the interest from industry is definitely very high. From academia point of view, for example, the National Science Foundation of US has sponsored a very large platform, this testbed platform. So they sponsor two large testbed platforms. One of them is called Cosmos. It's hosted by Columbia University and others in the New York City. And Nokia is one of the key industrial partners. There, the aim is to establish a city-scale wireless testbed, so that in that the basic communication infrastructure is they both provide a lower frequency like traditional cellular, but also at 28 gigahertz this millimeter range. So those provide the coverage service in the large city area. In the meantime, this platform is meant for various research and educational entities. They test their own concept. For example, they will have opportunity to test the fiber backbone between the data centers, the application from the end-to-end using through this both fiber backend and to the wireless, to the end users. And they also could test other applications like smart city. So they have a academia-driven and academia-operating hardware system, the whole system testbed for envisioned for 5G and the future. And they hope that this platform will facilitate both conceptual verification, but also experimental test to foster those new growth opportunities. And I think that's right now, for example, in Colombia, we have very close collaboration. They have done millimeter wave measurement in those Cosmos deployment areas using our sounder, and we have close collaboration in terms of designing the experiment, understanding the channel, and do proper channel modeling. And I think, at least from US point of view, the interest is very high. And also in here, like the reason we come to Chile, come to Valparaiso, is we have close collaborators here, both in USM and also PVC. And I think we also have, first of all, the main focus here is more on scientific curiosity, right? We want to understand what's the difference of the channel propagation from communication purpose when you increase the band frequency from a lower band traditional cellular to higher frequency. And exactly here, USM and PVC, you guys have the instruments, have the apparatus to measure both at lower band and higher frequency. And we come here to discuss for example, in the deployment areas here around the university, what's the kind of interesting scenarios that you guys could measure both at 3.5, say 28 and 60, and we compare the results and to verify a few hypotheses to see how large or how weak the frequency dependence would be and what's the consequence for telecommunication deployment by moving to upper frequencies. Yeah. So so it's have both application about understanding the fundamental propagation mechanism and also the implication on the deployment. I think the contribution, the expertise we can bring in to the table. We means Nokia Bell Labs, our industry expertise is to both some insight regarding which propagation, which fundamental aspects is more relevant for business, and also what's the consequence of the difference to the real deployment. I think our partners here bring to the table of collaboration is like you guys have excellent expertise regarding design and manufacturing those research instruments, and you have very great thorough, you have very good educated students and researchers. You have thorough experience of doing measurements and analysis. So I think, I really appreciate this collaboration, And that's why we want to come here in person to discuss in detail what's the research plan for the next steps. I think this I'm very confident that this collaboration will be very fruitful. The key challenge, so millimeter wave research is not new at this stage. It has been pop up in the air for at least 5 years, right? There's many researchers around the world from different top universities. They have done various kind of millimeter wave measurement in many different kind of settings. And what we found, of course, they generated a lot of interesting results, published a lot of papers at prestigious journals, make a lot of impact. And that also caused basically, the industry also put a large effort to standardize the communication at millimeter wave range. That's one of the key features for 5G actually. So the business behind those are huge. And on the other hand, what we notice is that the understanding of the channel at millimeter wave is not as solid as what we would hope to. Many of the early measurements, they put this way, is their data sets are not large enough, and the way they carry out the measurements is not as rigorous as we would like to see. So many of the results cannot be used for reliable, say, system level estimations or system level design. And as a matter of fact, whereas in US, 2 major operators deployed their service at a millimeter wave. And to their surprise, but not too much of our surprise, the performance is not as good as expected. So because the fundamental understanding of the channel is lacking. That's why in the past 2 years, we collaborate with USM and PVC. We have done extensive measurement to characterize the propagation characteristics at 28 gigahertz, that's millimeter wave band, both for indoor offices and suburban fixed wireless access, right, to provide high-speed access to suburban residents, but also the high-speed access in urban cities. So those are 3 typical deployment scenarios. And we have done those measurements. Most of the results has been, we have analyzed data to some extent, and we published a few papers, and we have another few general papers in the pipeline to be published. So it's very fruitful communication, but there's new things. So those are questions we believe I answered in a satisfied way, that we have quite a huge amount of data set. We have high confidence in the results we published. But there's new application scenarios yet to be answered. For example, the very hot one currently is the industrial IoT, so industrial Internet of Things applications. The vision is saying in the future manufacturing setups, you would like to, there will be a lot of robots, right? And you want to automate most of the process. And at the same time, you would like to high quality control of your system. You want to know, like, you would like to high definition videos feed from various parts so that you know what's going on and you could react fast in case there things happens. All those means you need to provide high-speed access in a lot of spaces in the industrial setting. The key difference from a factory and say a residential home or offices is that in industrials, you normally have large open space with a lot of metal objects. And those metal objects can be big machinery, can be assembly lines, very diverse environment, very distinct from offices, even like open office with cubicles. Well, the measurement in those environments is very scarce. there's only few, and there's a lot of interesting propagation phenomena. You have a lot of metal objects, a lot of reflection, scattering. What's the best way for describing the propagation in those environments? And it's yet to be established. There's many hypotheses, and we would wish our new measurements would verify that, right? So this IoT is definitely very hot right now. And the other thing would be, say, in many places, right? Some residents has high-speed internet through fiber, but fiber is not deployed everywhere. And in many places, even in the same place of the same city, maybe in the downtown area you have high speed, but many places you do not. And the cost to install fiber to every whole household extremely expensive. And I think many people envision in the future high-speed internet access is a facility, is a kind of a commodity, or this kind of utility has to be provided to virtually every household. How to achieve that in a cost-efficient way? And many people now, both in industry and academia, believe wireless may be a way to do it. But how, so we believe is that it is doable, but as a kind of researcher or system engineer, we would like to quantify that, right? We would like to say it's not only a belief, but if we could say this is how good you could do at a certain range, then either it's doable or how much the cost will be, that's we could leave them to business and government to decide. But at least we can tell them something, how feasible that is, how good, how bad the system would perform. And but that would at least not require understanding of propagation from tower or to lamppost to your external of your building, but also into the homes. And I think that's one of the interesting phenomena is yet to be explored. And we believe maybe in the next few months, we should have some answer on that. So for project per se, right now, I think the millimeter wave communication we considered as like a few years project, right? In our collaboration, I guess from a university point of view, you have dedicated project cycles, different names. But from our point of view, we put everything under the same umbrella. It's a meaningful research, it's the fundamentals, and it's long term. So we do not have a specific deadlines or specific boundaries regarding this is project 1. It was finished this month. We start project 2. No, that is not how our industrial research lab, at least Nokia Bell Labs, operate. Yeah. Yeah. So I think that's actually a very good question in the sense that the perception by many of the public is that right now we are satisfied with whatever we get. And we have cell phones, we have signals, we can access internet whenever we want, at least in most places. Like when I see in office, in my home, I have Wi-Fi. Yes, that's indeed both the perception and I think most of the case is the reality, right? Especially in downtown. So there's two things. One is actually someone calls the digital gap. Is this high-speed internet access is not uniformly provided to every citizen. It's normally if you live near close to city center, you have a good infrastructure to provide you the high-speed internet. You benefit from that. And if you are living or working in a neighborhood where they have a high commercial value, the operator would provide sufficient coverage. But once you are out of these two categories, And there's not much business incentive for the investment, and the coverage is poor. And in many rural areas, the high-speed internet is never, is never true. Is a dream that hasn't been realized. So I think one of the issues we need to think about as a researcher is how could we design the system such that providing the high-speed access to a large portion of the consumers would be cost-effective enough so that those people could also get similar service as people living in the downtown, right? So that's we try to make the wireless more accessible to more people by some creative engineering methods. Yeah, that's one thing. The other thing is think about for wireless communication, right? So is every problem in terms of wireless communication being solved? Or the other way, is there anything left of scientific importance need to be discovered in wireless? And I think we need to rephrase this question in this way, right? If the sole purpose is to solve point-to-point communication in a known environment, I would say majority of the problem has been solved. But the reality is the point-to-point is oversimplification of the real communication systems. And also the biggest challenging by moving to the millimeter wave is the traditional understanding of a channel and of propagation is that you can ignore the site-specific features. You don't care, is your home or my home, is the distance which matters. You do not care if your office or my office, because of furniture, also things, doors, house materials, because at lower frequency, those things doesn't matter. But what we found through measurement is it matters a lot at higher frequency. And so the location specific, or more like, so the term we use in our own domains is site-specific understanding of the channel is very important, or has to play an important role in the overall system performance. So that's give a big challenge for the system design. How do you design the system to provide satisfactory service to users in a very diverse environment, right? The naive way would be, I look at the worst case and do the system provision targeting for that. But that will be a huge waste of your resource. The worst can be very bad. If you always try to make sure the worst guy gets the service, the cost, it won't be very cost effective. So there is a thinking both on the system level research, but also on the fundamentals. Maybe it's time for us to relook the fundamental transmission schemes we used at the current wireless systems. This has been used in the past 30 years. The same concept there. We should revisit there to see if there's another ways to do so that the system is more agile in such diverse environment. And if there's some feature of the system we should enable so that the system could self-adjust, right? So those are open questions for us to see what's the best way to approach those challenges. And we of course, first we need to have a fundamental understanding what those diversity means from propagation point of view, from fundamental of the channel. Once we could characterize that, and then you see, okay, this is a different site, based on our understanding, the channel would be such and such. So that's how we see why we need to do the measurement in this direction, or continue to do the research in this direction.